Good day. Now let's discuss how to find the domain of some functions. Recall that the domain of the function is the set of all possible inputs for the given function. It means that all the values that we can replace for our x, if we replace it on a given expression of a given function, then it will give us an answer. Okay, so in this case, if there is a specific answer, then we get x is part of the domain. But if we substitute, say for example, a in a given expression and there is no answer, or in our calculator it's error, meaning that element is not part of the domain. So specific example, say for example f of x is equal to square root of x. So this is our function. Question, is 4 in the domain? So let's substitute. So f of 4 is equal to square root of 4. So square root of 4 in this case is positive 2, since I did not write plus and minus outside, so it's just the positive square root of 4, which is positive 2. So meaning, yes, 4 is part of the domain. Now question, is negative 4 part of the domain? Now take note that in our case, we only consider the set of real numbers as the biggest set. Now, we only consider this as our biggest set. Now, if x is equal to negative 4, is it part of the domain? So we have square root of negative 4. Now, in this case, we don't have any square root of a negative number under the set of real numbers. So meaning, now you may try to use your calculator, but the answer is error or undefined. It means that negative 4 is not part of the domain. So again, it is the set of all possible inputs for the given function. Now we will only discuss these three types of functions. First, a polynomial function. Now, a polynomial function is of this form. The next, we have a function of the form f of x is equal to square root of x, just the previous example. And number 3, rational function. So it is given by f of x is equal to p of x over q of x, where p of x and q of x are polynomials and q of x must not be 0. Now let's start with the polynomial function. So in this case, if you're given with a function and then if it resembles a polynomial function which is of this form, where our ai's are coefficients or constants, meaning they are specific numbers, and n is a positive integer or 0, meaning the exponent must not be fractions, then of course the domain of this polynomial function is always the set of real numbers. Or in interval form, we have negative infinity to positive infinity. Remember the number line. So this is the number line. This is the illustration of the set of real number. So the left side is of course the negative infinity. We also have the 0 at the center. We have the negative numbers at the left and positive numbers at the right. And towards the right is the positive infinity. Now in this case, all you have to do is first you need to check whether the given function is polynomial in form, because if it is a polynomial function, then automatically the domain is the set of real numbers. So you only need to check this, the exponent of your x, so it must be an integer or 0, and of course your x here are not they are not in fraction form. So by the way, when we say in fraction form, so I guess that depends on the exponent n, because if the exponent is a negative integer, then of course it will be in fraction form. No, remember x raised to negative 1, for example, is 1 over x. So it will become a irrational form. Now in this case, if you can see, there's no rational form for every term of the function. When we say rational fraction form, so for example, we have f of x is equal to 3x squared plus x minus 1. Okay, so meaning the n, our n here is 2, right? The highest exponent is 2. Then we have n minus 1, and then we have the a sub 0. So if you notice the exponents here, so that is x raised to 1. So the exponents here are all positive integers. And of course, the last one is raised to 0, but that's the constant. Okay, so anything that's looks like the polynomial function. So you can have 5x 19 minus 3x 15 plus 12x9 minus 3. So this is still a polynomial function. So of course, where our n here is 19, the exponents here are all integers. Okay, so these two are examples of polynomial functions. So automatically their domain is the set of real numbers. Okay, so there are lots of polynomial functions as long as they satisfy this requirement. Next, function of the form f of x is equal to square root of x. First of all, this is not a polynomial function. Why? Because by definition of nth root, if we have this is equal to a raised to 1, or say for example if we have m here in general, so we have m over n. So meaning our exponent here is not necessarily an integer, because here in the polynomial function the exponent must be an integer. So in this case, this one is not a polynomial function, because by applying this one, this is just equal to x raised to 1/2. So 1/2 is not an integer. So it does not belong to example number 1. Now, how do we find the domain of a function of this form? Of course, since we are on the set of real numbers, we are not in the set of complex numbers. So this has only this has a value if our x is greater than or equal to 0. Okay, so x is greater than or equal to 0. So most of the solutions here, or all of the solutions in finding the function of this form, starts with this one. We always start with this one. Okay, now if the given function is just like this, automatically the domain is x greater than or equal to 0, or in interval form, the domain of f is from 0 to positive infinity. Why? Because this means that x is greater than or equal to 0, meaning 0 is the smallest value of x, because x must be greater than or equal to 0. Now let's apply this one. Find the domain of the following functions. So for number 1, again, we will start at 6x minus 3. It should be greater than or equal to 0. And then we do the algebra. As much as possible, of course, our x must be positive. So we have this, transpose negative 3, so we have positive 3. And then we divide both sides by 6. So we always divide by the coefficient of the variable involved. So here we have x is greater than or equal to 3 over 6 is 1/2. Now, how do we interpret this? Now look at the interval form. So we have the negative infinity, we have 1/2, and we have the positive infinity. No, the 1/2 is from here, from the solution. Now, x is greater than or equal to 1/2, meaning where are the values of x, or on what side of 1/2 are these x's are. So x here must be greater than, or they are greater than 1/2. So of course, the values here are less than, right? We need the values greater than 1/2, so which is here. So meaning the domain of our f here is, we start with 1/2 to positive infinity, because greater than or equal to 1/2. Okay, next let's go to number 2. So again, we start with 20 plus 6x over 2, which is greater than or equal to 0. Okay, then we can cross multiply. So 0 is just 0 over 1, so we can cross multiply. So we have 20 plus 6x times 1 is just the same, 20 plus 6x, but 2 times 0 is still 0. Okay, so do the algebra again. So 6x, I will transpose 20, so we have negative 20. Okay, and divide both sides by 6. Negative 20 divided by 6. So I will continue it here. So cancel. So we have x is greater than or equal to negative 20 over 6. So what is the lowest term of negative 20 over 6? Now take note the factors of negative 20. We can rewrite this as negative 2 times 10 plus 6. We can rewrite this as 2 times 3. So we can cancel out 2. So therefore our x must be greater than or equal to negative 10 over 3. So greater than, so the same with this number 1, it's greater than, so it must be on the right, at the right of negative 10 over 3. Okay, the x's are greater than negative 10 over 3. So the values must be to the right of negative 10 over 3. Okay, so this is the domain of H. This is the domain of H. Another example, g of x. So again, we start with 11 minus 2x greater than or equal to 0. Now there are two ways in solving this one. You may transpose negative 2x on the other side, or we can let it stay on this side and then transpose 11, so that will become negative 11. And then we divide again by the coefficient of x, so negative 2. Now in this case, by the rule of inequality, if we divide both sides by a negative number or multiply both sides by a negative number, the direction of the inequality will change. So from greater than or equal, it will become less than or equal to negative 11 over 2. Okay, now let's check if we have the same answer, if we will transpose negative 2x. So say for example we have this, so retain C11 greater than or equal to 2x. So again, divide both sides by 2 because this is the coefficient of our 2x. So we have negative 2. So negative divided by negative, so this is the final answer here is positive 11 over 2. This one is 11 over 2 greater than or equal to x. Okay, these two have the same answers or interpretation. For this part, for the first one, it means that the excess, so say for example, we have here 11 over 2. The excess are less than 11 over 2. So meaning this portion, they are smaller than 11 over 2. Now on the other hand, for this one, 11 over 2 is greater than or equal to x, meaning 11 over 2 is greater than. If 11 over 2 is greater than, therefore the excess must be also here. So either of these two solutions have the same answer. Okay, so you can have either of these solutions. So therefore, the domain of G is from negative infinity. So since this is negative infinity, we always start on the left side from the smaller number to 11 over 2 bracket. Okay, so negative infinity to 11 over 2. Okay, last example for this type of function. Now we have 5 plus 10x is greater than or equal to 0. So I will retain here the 10x and then transpose negative 5. So divide both sides by the coefficient of x, so which is 10. So we have negative 5 over 10. So cancel, cancel. We have x is greater than or equal to negative 5 over 10. That is negative 1 over 2. So here it says that the excess are greater than negative 1/2. So when we say greater than, it's on the right or at the right of negative 1/2. Therefore, the domain of P is from negative 1/2 to positive infinity. Meaning, any values from this set of domains, if we substitute it to the given functions, we can have an exact answer. Otherwise, if you get out a number outside of this domain, then we will arrive at a 0 answer. Okay, so say for example on this one, negative 1 is not part. If x is negative 1, this will become negative 10. 10 times negative 1 is negative 10. 5 minus 10 is negative 5. So there is no square root of negative 5 under the set of real numbers. So it's error. That is why negative 1, which is located here, is not part of the domain. Okay, last set of function is the rational function. So we have this. So since this is a rational function, our denominator must not be 0. Why? Because if the denominator is 0, given that the numerator is non-zero, then it's error or undefined. We have no answer. So therefore, we must start with q of x must not be 0. Okay? So it must not be 0. So, or you can also start the opposite, no? You equate the denominator into 0. Because here we will find the zeros or the roots of the denominator. Okay? Because the roots of the denominator will be deleted from the set of real numbers. Because it will make the expression undefined. Okay? Say for example, find the domain of some rational functions. Number 1, 2 over x plus 1. So, what is the value of x that when we substitute that value, the result here is undefined? Okay, so meaning we'll start with x plus 1 equals 0. We will find the root of x of the denominator. So our concentration is on the denominator. So x plus 1 equals 0, and then do your algebra. So x therefore is negative 1. Okay, so it means that if your x is negative 1, if x is negative 1, this expression, the denominator is 0, right? It means that 2 over 0 is undefined. So the domain of f is just like this. It is the set of real numbers minus, that is a set minus, this value, the value negative 1. So since this is a set minus, we will use a set notation, a set containing negative 1. So we will just delete this value, because negative 1 will make this expression undefined. No, negative 1 plus 1 is 0. So 2 over 0 is undefined. We have no answer or error if you use your calculator. Okay, so again, number 2, again, we'll start with the denominator. So we have this. Negative 5x is equal to negative 10. So divide both sides by negative 5. So cancel. So we have x is equal to negative 10 over negative 5, that is positive 2. So meaning, if x is 2, this will become 0. Okay, so 10 minus 5 times 2 is 10, so 10 minus 10 is 0. Again, this will become undefined. So the domain of G is therefore the set of real numbers minus, again, the value 2. So the set containing 2. And last, so the denominator here is x squared minus 9 equals 0. So this is x squared is equal to 9. So getting the square root, we have the plus and minus square root 9. We have x is equal to plus and minus 3. So positive and negative 3. So if you substitute positive or negative 3, the denominator will become 0. Okay? So therefore, the domain of G again, so this is G, is the set of real numbers except negative 3 and positive 3. Okay, so I hope you learned something, and thank you for watching.